said you felt that way. And guess you're trying to stay strong and fake a smile until I look away. But I've known you too long, it hurts to watch your blue eyes fade to gray as you fade away. As you fade away. As you fade away.
Already mic testing, mic testing. Okay, perfect. Let me go to my main camera. There we go. Alright, we're live, and as you guys can tell by title and thumbnail, today I'm going to be continuing on, let's say, working on my project 2, which was me building a predictive model from scratch. Last stream, I was done with all the data cleanups and all that. This stream, I'm gonna actually work on writing the code that I will be using to, let's say, train my model. Let's go to my gameplay screen. There we go. And yeah, today I did not want to waste any time. I wanted to be done with this last stream because today is day 101 and I want to start my fresh phase 3 today. But I guess we've got to delay that till tomorrow. Okay, let's go with something like, let's say, I'm live exclamation. And yeah, this is Clouds' brand new chat. I will be touch typing and following a 25 to 5 minutes with Pomodoro session where every 25 minutes I get a 5 minutes a break, and every 4 sessions of 25 minutes I get a 10 minutes break. That said, I'm gonna start the timer in 3, 2, 1, and let's go. And one annoying thing is I can't start the damn timer without, I can't kind of shrink the timer without really starting it. Okay, that said, there it is, let's go. There it is, let's close this out. Day 101, you've done the hard part. I know I spent over 9 days, or I think like around 9-ish days, give or take. I think last I checked it was 8, so tomorrow's stream would have made that be 9. It may be 9 or 10, fact check me on that. But I spent that time cleaning my data. The math part, the debugging, the derivations, is that how you pronounce it? Today you don't touch a single new formula. Today you prove you can turn hard numbers into something a person who's never heard RMSE would actually understand and trust. And yeah, in case you guys couldn't tell, I'm not warmed up yet. Usually I kind of warm up before I start streaming, but today I did not. That's a different muscle, and it's the one that separates one who can build a model from someone who can get paid to build one. One task stands between you and phase 3, the client write-up. Okay, and MAE and RMSE are basically, MAE stands for getting the absolute value of an error, while RMSE is squaring the error, which basically means if we get an absolute value of a negative number, it turns into be positive, and any number squared is a positive value as well. So they turn all the negative errors into positives. But RMSE, since it squares the numbers, is always greater than MAE, which just gets the absolute value. Mean house value equals to $192,000, and MAE is roughly a quarter, 24% of the mean. The RMSE-MAE gap tells you some houses are missed by a lot than typical 24%. I see. Yo, Hiding Pixel, appreciate you joining the stream. Remember me? Actually, I've got a bad memory, but I may remember if you actually tell me something about let me check. Hold on. Hold on. There is one timeout. Okay, my memory is awful actually. Although let's say hold on. Let me go ahead and eat something real quick. Okay, before we draft, you already know who this fictional client is supposed to be. A real estate firm, city planner, just a client, generically, hold on, it changes how technical versus plain we go. Okay, hold on. The more the longer the stream goes on, the more warmed up I'm gonna be. I can't read squat here. Before we drop, do you already know who this fictional client is supposed to be? Oh, I see. Okay. A real estate firm, city planner, just a client, genrically. It changes how technical versus plain we go. You know what? I'll go with something like haven't thought about it. Your call. Okay, I guess I'll let Claude think about it. My call, real estate slash investment firm. Here's why. It's the most important natural fit for a housing price model. They'd actually pay for this. It gives you a concrete reason to care about accuracy. Would I trust this model to guide a purchase decision? And it forces you to translate RMSE slash MAE into something that maps to real financial risk, which is the actual skill here, not the writing itself. So you're presenting to a real estate investment firm that's evaluating whether your model is reliable enough to help guide buying decisions. Before I hand you the writing task, this is a reasoning work, not syntax. So I want to make sure you can actually explain the numbers out loud in plain English before you write them down. Answer this yourself, don't just skim it. Okay, and finally, this is the part. I don't really know how to work on a predictive model, but I don't know how to really work on building a model in general. So once I'm done with this, or maybe by the end of the stream, we're probably going to know how to do that stuff. If you had to explain to someone with zero data science background why are there two errors, MAE and RMSE, instead of just one, and why the gap between $45,700 versus $62,000 actually matter to a real estate investor, what would you say? Okay, has zero data science background. If they did have, now I made a crazy project in UEFI-OS. Wait, I actually have not heard of UEFI, but I do know OS is operating system. What kind of project are you working on? Okay, that's it. Let's see. If I were to explain this to someone who actually did have data science background, I would say that MAE, let me type it out. Okay, let me say something like, if I had to explain it to someone who had a data science background, I would tell them that MAE is not as harsh when penalizing errors. There we go. And hold on, let me fix my typer real quick. Okay, so MAE is not as harsh when penalizing errors when compared to let's say RMSE. Since RMSE gets squares the error, or squares an error, while MAE gets the absolute value of an error. Okay, there we go. However, if I wanted, let's say something like to say this, if I wanted to explain this to someone who has zero data science background, I would just say them. That. Okay, how would we explain someone with zero data science background? Do you rent college dorm? What's rent like normally? Well, actually, this is not a college dorm. It's basically an apartment. UEFI is a fireware like BIOS, and it starts before the operating system, which loads the OS. Oh, I see. That actually sounds really cool. Okay, that said, if I wanted to explain this to someone with zero data science background, I would just say them MAE is, or let's say MAE is for letting a model. How would we phrase this to someone with zero computer science background? What the hell? I would just say them that MAE does not punish as hard as RMSE. Yeah, that's the best I got. I need to work on my phrasing when it comes to explaining it to someone with zero background. That's the right core idea, but it's still living at the how the formula work level, not yet at why should I, an investor, care. Let's push it one more layer. You correctly said MAE punishes less harshly than RMSE. Good. Now the actual question I asked, why does why does GAAP matter to a real estate investor specifically? Oh, why does that gap? Think about it this way, I'll ground it in your own numbers instead of asking you to reason abstractly. MAE is $45,664.71. This is your typical miss averaged out evenly. RMSE equals to $62,051.13. This is noticeably higher than MAE. You already know RMSE is a higher. Wait, you already know RMSE is higher because it punishes big, misses harder, so flip it around. If RMSE is a lot higher than MAE, what does that tell you? Wait, what does that tell you must be true about some of the houses in your data set? Okay, it means that, not why RMSE is bigger, you've got that. I mean, why does a big gap imply about the shape of your errors across 3,935 test houses? Take a guess and reason it through. Don't just restate the formula difference again. Okay. If RMSE is a lot higher than MAE, what does that tell you? Must be true about some of the houses in your data set. Okay, so, let's say it tells me that. I could go with something like, it tells me that. What does it tell me? What does it tell me? It tells me that flip it around. You already know RMSE is higher because it punishes misses harder. So flip it around. If RMSE is a lot higher than MAE, what does that tell you? Must be true about some of the houses in your dataset. It tells me that some of the houses, oh god, it's some of the houses in my dataset has been exaggerated to be pricier than it should be, or should have gone with the pricier than the market value. Okay, but I'm gonna go ahead and send it here. There we go. I think that was correct, right? Mac OS, even Windows uses it, and it's almost all Linux distros. I see. I actually haven't worked with Linux when I was actually building my PC. Many of you guys did tell me to get Linux instead of Windows, but Linux does has a lot of capping besides the programming genre. However, I did fix that up by actually getting Linux on my Windows using Ubuntu's WSL. Okay, there are a bunch of things here. I don't see WSL here, but it's kind of funny that I can now use Linux and Windows as well. Okay, that's it. That's a guess reaching for an answer, not a trace of reasoning, and it's actually not right. Slow down, don't just pattern match to expensive slash exaggerated. Let's rebuild this from what you actually know. You already correctly told me RMSE punishes big errors harder than small ones because squaring inflates large numbers way more than small ones. You derived that yourself. 10,000 to the power of 2 is 200,000 back on day 100, which was yesterday. So walk it backwards with me, one step at a time. Step 1, if all 3,935 houses in your test set had roughly the same size error, every single house was off by close to $45,000. What would squaring those errors and then square rooting back out change the average? Wait, what would squaring those errors then square rooting back out change the average? Very much compared to just taking the absolute value. Okay, in case you guys are thinking, why do we need to square the errors then get a square root? That's because we square our negative values. So our errors are our negative values. We square that up to be a massive number. Then we square root that number to get it back to the positive number. For example, if I square 10 grands, it's gonna give me 200,000. Okay, if I squared negative $10,000, it's gonna give me positive $200,000. If I get the square root of positive $200,000, I'm gonna drop down to a positive 10,000 just to remove the minus sign. Would squaring those errors and then square rooting back out change the average very much compared to just taking the absolute value? It would not. It would not, to be honest. Because, let's go with something like, because when I square, let's say, 10k, it gives me, let's go with negative 10k. When I square negative 10k, it gives me positive 200k. And then the square root, SQU, square root of, let's say, positive 200k is gonna be equal to positive 10k. Okay, and then let's see. Furthermore, the absolute value of hold on, ABSOLUT. Furthermore, the absolute value of positive of negative, let's go with something like negative 10k, is going to be equal to positive 10k. Yes, it doesn't change anything, bruh. Hold on, let me eat some fruits real quick. Wait, careful, check your arithmetic before you move forward, because that's not what happens with negative 10k. You said square negative 10k to positive 200k, then square. Then the square root of 200k is 10k. Wait, is it not? Actually computed. What is negative 10,000 to the power of 2? Wait, hold on. Let me check that real quick. Oh, bad, my math is not that good. Okay, hold on. Let's go with something like negative 10,000 to the power of 2, right? So I'm gonna go with multiplied by negative 10,000. Shouldn't this give me something like a million? Oh, wait, never mind. It's 20. Wait, I went with... Oh, God, I went with subtraction. Hold on. Let's go with something like negative 10,000 multiplied by negative 10,000. Did I go with subtraction twice? Wait. 10,000 multiplied by 10,000. Okay, it gives me 100 million, so negative would be positive. Oh, God. Wait a minute. Negative 10,000 multiplied by negative 10,000. Am I going with multiplication? How is it giving me 20,000? Wait. Negative 10,000. Okay, wait. Negative 10,000 multiplied by negative. Oh, I see. I'm going with the minus sign here. Oh, God, wait. How do you do that? Minus cancel each other out as positive. So we get like 100 million, right? Let me go up here real quick. Let's go down here again. Okay, I think I see. Let me just get the number real quick. Okay, so it's whatever this number is. I think it's like 100 million. Okay, and then I'm gonna go ahead and clear that and let's send it. It gives me this number. Right, 100 million, not 200,000. Good catch in your own arithmetic. That's exactly the kind of thing I want you catching yourself, blah, blah, blah. Now, redo the rest of the chain correctly. The square root of... Oh, God, I gotta find the square root of 100 million. And once you have that, answer the step 1 question again with correct numbers if every house in your test sets roughly to the same size, all close to 45,000. Would squaring then square rooting give you a result close to taking the absolute value? Okay, I think for this, I may need to actually grab this. Okay, what is the square root of 100 million? There we go. Okay, it's 10,000. Okay, the square root of 100 million is 10k. Interesting. Okay, I did not. Okay, good. Square root of 100 million is exactly 10,000. That confirms that squaring negative 10k and square rooting a back out just gives you 10k again, same as the absolute value. So now, step 1 for real. If every single house in your test set had roughly the same size error, all close to 45,000, none widely bigger or smaller, would RMSE squaring then square root end up close to MAE or way higher than MAE? Oh, wait, I see. Okay. Hold on. If every single house in your test had roughly the same size, error, all close to 45,000, none widely bigger or smaller, would RMSE square root then root end up close to MAE or way higher? Okay, let's check that. Let's test that real quick. So I'm gonna go with something like 45,000 multiplied by 45,000. So these are roughly all the errors that we get. Is that 2 billion or 2 million? Ones, tens, hundreds, thousands, 10,000s, 100,000s, a million, 10 million, 100 million. I think it's 2 billion. I think that's 2 billion. Okay, what is the square root of this number? Wait a minute. I'm gonna copy that real quick, and then we're gonna go up here real quick. I'm gonna go with something like square root of this number. Yeah, I kind of forgot how to find square roots. So it's 45,000. My bad. Of course, we're gonna get 45,000 if we get a square root of this. So MAE would be the same. It's literally the same. They would be exactly the same, to be honest. There we go. I may eat an apple. Hmm. When errors are all roughly uniform in size squaring, then rooting behaves mostly like just the absolute values, so RMSE and MAE land closer together. Isn't it literally the same? Oh, I see. With different values, they land closer together. Okay, you know what? That actually makes sense. If all errors are close to, let's say, 45,000, of course, both of them are going to be landing to a closer number. If they are, let's say, a different errors, RME and RMSE will be different. In your actual results, RMSE 62,051 is noticeably higher than MAE, which is 45,664. Not close together like the uniform error case you just reasoned through. So, if uniform errors gives you RMSE equals to MAE and your RMSE is way bigger than your MAE instead, what does that tell you about your actual 3,939 errors? Are they all roughly the same size or is something else going on? What are you building? Actually, I'm working on building a predictive model. I have been working on this for the past, let's say, I think it's approaching the 14-day mark. I mean, actually, no, man, it's approaching the 10-day mark. I've been working on this for the past 8 days. I think today is the ninth day. Let me fact check that. Hold on. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so I've been working on this for the past 11 days, and today I actually want to be done with my entire machine learning concept, and tomorrow we'll move on to my phase 3, which is deep learning. But this has been so confusing. What the hell? Okay, wait. Actually, let me just read this part again. So, if uniform errors gives you RMSE equals to MAE, and your RMSE is way bigger than your MAE instead, what does that tell you about your actual 3,935 errors? Are they all roughly the same size or is something else going on? Okay, to check that, let me go ahead and remove the, or get me the square root I think this is the square root. So in your actual results, that is my square root is noticeably higher. I don't think this is a calculation stuff that we need to do, right? Hold on. Not close like uniform. There is a massive gap here. I think there's like, what is 62 minus 45? 62 minus 45. 17 thousands is error. Okay. I mean, difference. Are they roughly the same size? I mean, in a huge scale, they could be considered roughly the same size because the difference is only 17,000. Let's go with something like dollars, while let's see, the difference is only 17K, while in a small scale the size is not the same because let's say a product, but this is not about product. Let's say, there we go. Because I was gonna go with a product example, like paying 17K more in a product is an absolute should I say worst purchase. So you're building a machine learning algorithm from scratch, or what do you mean? Actually, I'm building a predictive model. So what this is basically gonna do, it's sort of gonna work like a real estate firm where every time before we really go ahead, or let's say we give our model a certain data. For example, I got my data from Kaggle, but if we give it a data in general, it's gonna go ahead and tell us which house is a better purchase. There were a bunch of other options, but this was like the most complicating one because it covers like almost all the topics that I did work on. But you know what? I haven't really worked on building it yet. I've just been working on the prerequisites to actually be able to even work on learning this model. So when I actually write the program, that's when I'm gonna understand more about it. Oh wait, that said, hold on. That's the break time up there. Okay, and yeah, I'm following a Pomodoro, so I'm gonna just go ahead and let's say grab chess here. Okay, and I wanna actually play a coach again. One bad thing about chess is that, or chess.com, is that they don't really let us play with coaches more than once every single day. So that's so annoying. I gotta play with bots. Okay, I think I'll go and play with a coach. But I want to be done with this. You know what? Today I may not take breaks in general. I want to be done with this so bad because yesterday was the 100-day mark where I should have been done with this. Apparently I did not. But I guess today I'm gonna go. Should I play with someone? Or should I play in an advanced level? I think that's good enough, right? Okay, let's get this practice game going. We'll dissect it later. Alright. Okay, so first things first, I'm gonna go with, let's say, E4. This is a really basic project. How do you spend 2 weeks on it? It's not even intermediate. Okay, you know what? I am basically an absolute beginner at this stuff, but you know what? It's not really, I can tell it's not really that hard. I just wanted to get my basics down. Okay, I'm gonna get this here. This may be a bad move.
You still have other pieces to develop. Wait a bit before bringing out your queen.
Okay. Yeah, I was gonna go ahead and grab the pawn there, but now it's a bad idea. But I would need my queen in general, so I can do the king sides this castle. Oh wow, that's a great move. If I take that, will it be a great move? Okay, another great
You
move.
have a pin on one of my pieces. Can you add to the pressure?
Have a pin at one of the pieces? Can I add to the pressure? I have a pin. I have a pin. Oh, actually, yeah, I do have. Oh, I do have a literal pin. If I were to go there.
We're playing it cool and getting out of your threat. Logic for the win.
No, a great move. Okay, how am I the only one that never has great moves? Okay, wait. That's gonna be a fork. I need to avoid that fork from happening. How do I do that? I could go ahead and let's say get my knight somewhere here, but if they take that fork is inevitable. Unless I go there. That's the best move.
Ooh, adding more pressure. We've got another piece attacking that pawn now. You're
Adding more
piling up
pressure.
the pressure on our knight. Like, it's looking like it's in trouble.
I'm
Free
down
pawn.
here for a fork as well. Wait. Oh, okay, the pawn is free. Uh-oh, this doesn't look good. I could take that, but I'm gonna go... Oh. You know what? I will move my king for now. Although, we're gonna go ahead and do that. Yep, we're all doing bad moves. Oh my gosh. Wait a minute, wait a minute. Wait, that was the queen, not the king. Oh. Did I by any chance waste my coach gameplay here? I could potentially wait, actually? Yeah.
Ooh, adding another attacker into the mix, we see you building that pressure.
Never mind. We're good. Great move, Fark.
Blocking the
Let's
check
go.
because of safety first, Avi.
Blocking the check. I'd say that's a bad move.
You took our attacking bishop. Noise. Time to develop our bishop. You see, we gotta get it in the game.
Wait. Could I by any chance get rid of the bishop before it even... A double check?
Time for the king to boogie on out a check.
No. There is no going out of the check. Well, actually there is kind of, but... Most of my pieces are inactive. What the hell? Hold on. Can I like go there? Nope. I can't. Okay. What if I move here? A blunder?
Take a look. I can now take your undefended rook.
Oh. You know, since I'm playing with a coach, I can actually... Oh god, I gotta protect my pieces.
Nice save. You saw our threat and totally avoided it. Good eye.
Bye-bye, horsey.
But why is it so hard to play with advanced level? Okay, I'm gonna move here. Oh god.
Yes, the royal fork. This is literally the most satisfying move ever.
Another royal fork. Wait. 1, 2. Okay, at least it's not a triple royal fork. That's fine.
Gotta move that king out of the fire, as expected.
Yeah, you know what?
You left a queen undefended. Thanks for the freebie.
Well, I did not... Okay, that was the creepiest love, but I did not have any other choice.
You took over the open file. Yes, we love that. Rooks belong on open files.
I think
Can
there's
you spot
no way...
the threat we made?
Okay, look, there is no way I'm winning this. I'm just gonna resign because I need to also work on this project, and that was the break time as well. Okay, that said, let's slow down here because you're edging towards they're kind of the same, but you already did the reasoning that proves they're not. Go back to what you just established in step 1. Your errors are genuinely uniform. RMSE and MAE come out essentially equal, not 17,000 apart. Basically the same number. That's what close together means in this context, not close relative to 192,000 mean price houses close to each other. So a 17,000s gap between RMSE and MAE is not small. It's actually a meaningful gap relative to MAE itself. 17k is roughly a third of 45,000. Oh god, it is. Wait, are still on this house project? Actually, yeah, I am planning to be done with this today and start with deep learning tomorrow, but apparently these concepts are getting way too complex. Here's a direct question again. Answer it as a binary first. Are your 3,935 test errors uniform in size or not uniform in size? They are not uniform in size. Okay, this is all about data understanding. The reason I'm not really rushing through this entire, should I say, phase is because I do not want to make the same mistake that I made like for my programming for 250 days series. There, I quickly rushed one concept after the other without really understanding, and we wouldn't want that this time because I would have to come back and relearn these things. Rather, I'll just learn them nicely the first time. I don't think you're ready for deep learning. What's deep learning even about, to be honest? I haven't worked with half these concepts. That's not uniform is vague. Let's make it concrete. You know RMSE gets dragged upwards specifically by a large error because squaring inflates big numbers disproportionately. Your RMSE being pulled well above your MAE means something specific about the shape of your errors, not some houses are exaggerated, but something about how many houses and how bad their errors are. Here's the grounding question. if you had 3,935 test houses and most of them had small to moderate errors. If you had 3,935 test houses and most of them had small errors to moderate errors, say close to like 45,000 typical miss, but a small number of houses had errors way bigger than that, like 150,000 or 200,000 off. What would that do to RMSE compared to MAE? RMSE would actually punish them way more than MAE would. That's literally the only explanation here, right? Think of it like this. MAE treats every dollar of error the same, so a few huge mistakes just gets averaged in gently with everyone else, while RMSE squares the first. So what happens to RMSE's is average when a handful of errors are way bigger than the rest. The only reasoning that I can think of is that RMSE will be more strict when the model makes errors. Because, let's go with something like, because each error has been squared when compared to, ignore the typos, when compared to MAE, since MAE just gets the absolute value. Okay, but here's the thing. Let me go with something like, am I not understanding a key concept or something? Huh. Okay, wait. I wanted to fix my typos before I send it, but it's fine. Honestly, right now you're depending a lot on Claude. I think you should try to get some concepts fully on your own, like use documentation, but like conceptually understand it yourself. That's actually what I'm doing using Claude though. Like I do explain the topics, but then I do understand the topics once I invest enough time in it. First, learn an LMP. Ask Claude about it. I don't want to kind of mess that up because I am following a roadmap actually. Hold on. Okay, but you're not missing a concept, because I understand the concept. I'm trying to understand what Claude is trying to explain. What the hell? Okay, you're circling the mechanism. Squaring punishes big errors harder without landing on the conclusion it produces. You've actually said this correctly like 3 times now. I know, that's what I'm saying. That's literally what it does. Let's stop re-explaining the mechanism and force the conclusion out directly. Here's the mechanism one more time, stated plainly so we're all aligned. A few large errors contribute disproportionately more to RMSE than they do to MAE because RMSE squares them first. That does make sense, okay. Now, direct, concrete question. Answer with a house price story, not a formula. Imagine your 3,935 test house splits into 2 groups. Group A, most houses. Errors are small, clustered around 30,000 to 45,000. Group B, a small handful of houses. Errors are huge, like 150,000 to 250,000. If RMSE gets dragged up by Group B's giant errors while MAE barely notices them, since MAE just averaged everything evenly, what does that tell a real estate investor about which house your model is trustworthy for and which one it is not? Oh, I see. Okay. So, model is trustworthy for, okay, answer in terms of trust the model here. Don't just trust it there. Okay. Trust model A because model B errors because the errors in model B are huge. There we go. Claude can think for you. I'm trying to, it's like prompt engineering. I'm trying to prompt Claude correctly so it can actually get me to think. But you're still bouncing off the formula instead of answering what I actually asked you. Okay, hold on. Let me focus. I think I need to be a little hydrated, right? Hold on. Let me drink some water real quick. Okay, but by the end of the stream today, I will be actually understanding this part. I don't care if I go on for like 8 hours today. I want to be done with this. Okay, stop. You're still bouncing on the formula instead of answering what I actually asked. Let's reset cleanly because I think Group A/Group B got read as two different models when I meant to. Two different groups of houses predicted the same model. Rebuild it with me slowly, one plain sentence at a time. Your one model made predictions on all 3,935 test houses, okay? So one of our models made these predictions in the 3K houses. For most of those houses, the model was off by a small typical amount. For most of those houses, the model was off by a small typical amount, close to that 45,000. For a small number of those houses, the model was off by a huge amount. Way more than 45,000, maybe even 150,000. Same model, same test set, just some houses it nailed close to typical and a few houses it missed badly. Are you going to make a UI for it using what library? Okay, I'm not like literally building an actual model. I'm just understanding on how do I build it. I will be decorating and building a UI and doing all that stuff at the end when I'm actually, let's say, creating or building a fully autonomous agentic AI at the end of this series though. But for now, I'm just learning everything that I need to. These are all just the stepping stones to actually really work on understanding how to make these AIs. Okay, wait, now, plain English. No formulas. Finish the sentence like you're talking to an investor who's never heard of MAE or RMSE. How do I do that with just 14 days of practice? Okay, well, not even 14 days, like literally one day. I worked with MAE and RMSE like yesterday. For most houses, my model predicts you can expect the price estimate to be off by around 45,000, but for a small number of houses, the price can be off by 150,000. This is literally the only explanation that I can think of. Okay, you actually don't know that it's specifically 150,000? That was my example number to illustrate the idea. What do you know for certain? From your real RMSE/MAE gap. 17,000, that was our gap. It's just this. For a small number of houses, the model's errors is a lot worse than the typical 45,000. You don't have the exact same, you don't have the exact size of those big misses without digging further into the actual per house errors, which isn't required for this write-up. So here's the honest piece. So wait, here's the honest, precise version. Say it back to me in your own words. For most houses, my model's price estimate is off by 45,000. But the gap between my RMSE and MAE tells me that for a smaller number of houses, the model is missing by 17,000, meaning it's not equally reliable across all houses, and an investor shouldn't treat every prediction as equally trustworthy. 17K. Fill in the blank. Okay. You know what? I think I see. Oh god. Okay, what are we trying to get here? What am I trying to do here? Close on instinct, wrong on that. Wrong on what the 17,000 actually represents. Let's nail this down precisely because this is the exact number in your write-up line and you need to be able to defend it under questioning. The 17,000 is the gap between RMSE and MAE themselves. 62,051 minus 45,665. That's not. Houses are off by 17k. That's a diagnostic signal, not a dollar amount applied to any of the houses. Here's the distinction, plain and simple. 45,664 is the MAE, the typical everyday miss across most houses. 62,051 is the RMSE, pulled higher than MAE specifically because a small number of houses have errors much bigger than typical. The 17,000 gap between them equals to not a real-world dollar amount you tell an investor about a house. It's a signal that tells you, the model builder, that some houses are being missed by a lot more than 45,000. So, to be honest, defensible claim that you can actually make to a client is not a specific dollar figure. For those bad miss houses, you haven't calculated that. It's the most predictions are off by 45,000, but the... Oh, I see. Okay. Most predictions are off by 45,000, but the size of the gap between the two error metrics tells me a smaller number of houses have much larger meaning. The model's reliability isn't uniform, and some individual predictions should be treated with more caution than others. Okay. Good night, bro. I appreciate you joining the stream. I'll catch you next stream, Dark. Okay, that's it. Now say that back to me in your own words. So, okay, I got it. I would say an investor that the model is off by $25,000. However, let's go with something like a small number of houses are, let's say, prone to, let's go with some, I don't know how to phrase this, are prone to having larger errors than a typical house. There we go, then a typical house. Therefore, oh god, okay, therefore. Okay, so a small number of houses are prone to having large errors than a typical house. Therefore, RMSE treats errors much more harshly than MAE. Okay, let me add a side note and say I understand this. However, since I just started working with this yesterday, I do not know the right way to, I don't know, articulate what is it that I want to convey. There we go. I will get there by practice. Yeah, I cannot literally just start talking to, let's say, a client or something, for example, with just having 1 day worth of experience. You're closer than you think. Let's not move past this because the content of your understanding is actually solid now. It's just the phrasing that's tangled. Let me show you the fix, then you're done with this piece, okay? 2 small things to untangle. Off by $45 typo. You mean 45,000? Okay, I meant 1,000. Small, but in a client document, that typo changes the entire meaning, so always double check. Okay, it's not like I'm literally talking to a client. This is just a hypothetical example. You're explaining the mechanism again. RMSE treats errors more harshly instead of stating the conclusion. Oh god, the investor doesn't care why RMSE is higher. They care what it means for their money. Okay, I need to understand the topics, not know what an investor is going to think about. Here's the reframe, same idea, but leading with the conclusion first. Mechanism, if any, Second, on average, my model's price estimates are off by $45,000. However, a small number of houses show much larger errors than typical miss, meaning the model isn't equally reliable for every house. Oh, investors should treat individual predictions with more caution in cases where other red flags like an unusual property are also present. That's the client-facing version, not formulas, no RMSE or MAE jargon, just what it means for trust and risk. You don't need to have that phrasing muscle yet. That's literally what today's task is for. Now that you've got the real understanding locked in, let's pull it to work. Write the actual client right up. Okay, finally, here's the thing that I wanted to say, let's say 50 minutes ago. Oh god, I'm so glad I spent 50 damn minutes in this stuff. I understand now. So basically, RMSE and, I mean, when there's, let's say, a slight difference in house errors or in, let's say, a small number of houses when they got more errors than a large number of houses, that basically means RMSE treats errors different when compared to MAE, but that is still in the formula. The way that we could actually explain this to someone is that the model is not equally reliable for every single house because every single house got different errors. And if you try to uniform those errors, that would just make everything in our data set, that would make everything in our data frame static, and we do not want to work with a static data frame because real world data frame is never going to be static. Every single house is not ever going to be, let's say, just $45,000. There are price difference, or let's say differences in prices. That's where MAE and RMSE comes in. We pick which error do we want to have the model treat more. Should I say, what's the opposite of strictly? Treat more forgivingly, while the other certain kinds of errors, the model needs to treat it more strictly. Okay, that said, structure I want from you in your own words. No code needed today. What? I need code though. What the model does, 1 to 2 sentence, how accurate it is, MAE and RMSE stated plainly. Okay, what the model does. Let's go one question at a time. You're so loud. Wait, am I loud? Hold on, let me check my OBS real quick. Wait, so what's happening right now? On the same data set, I got like 16,000. Do you mean on like my data set? Wait, are you using the same data set as me from Kaggle? On the same data set, I got 16,000. Do you mean like a price difference or something like that? Okay, that's let's see. So, what the model does, 1 to 2 sentence. Okay, so what the model does, is that it goes over our data set and figures and returns, oh god, and calculates the errors. That's literally what it does, right? How accurate is it? The model is accurate. However, a small portion of houses has more errors than other houses. Therefore, then a typical house. Therefore, the model. Okay, I'm bad at. I understand the topics, like I literally do, but I don't know how to freaking phrase this stuff. The reliability caveat. The thing we just nailed down about uneven errors. How do I say stuff on that? Errors are uneven due to the difference. Due to the difference in-house datas, the line recommendation, would you tell this investment firm to use it and with caution? Oh, okay. Use this model. However, beware that the results will never be 100% accurate, since the errors vary from houses to houses. Dude, let me say, I literally understand and know what to say. However, it is hard to phrase it. And also, I thought that we needed to write code in order to build and train this model, question mark. Aditya, let this kid learn, however, blah blah blah. Okay, let's see. Also, I don't think that I'm a kid. Guys, I'm actually 18 right now. I'm a fully grown adult. Well, not really a fully grown adult, because that's when you're 21, but you know. Okay, students, hold on. Okay, two things here. Let me answer the code question first, since that's a real fair concern. Then we'll fix the draft. The code. You already built and trained the model that happened on day 100, linear regression.fit. Oh, wait, did I do it? I didn't even know that I built a model. I think I should be aware of the things I do, though. Then RMSE/MAE evaluation, all done, all verified, all sitting in your EDA.py. Today's task was never building a new model per the roadmap. Project 2's final deliverable is to write up your findings as of presenting to a client. I should have known that. Why didn't I know that? What the hell? Oh my. I spent 57 minutes working on how will I present this model to a client that I don't even have. Why would I ever need to do this? Okay, it's a good habit. It's a good habit to understand my model, but come on, I should have known. I thought that I'm gonna like actually write the code to build my model. Little would I have known that the draft model that I built here last stream using these lines was the literal model that I actually needed for project 2. All I had to do was, first things first, import a linear regression from my sklearn.linear_model and mean absolute error and mean squared error from my sklearn.metrics and numpy. And then I had to create 4 variables. x_train, x_test, y_train, y_test. I had to set that equal to the function that I included from my sklearn.train_test_split. Well, sklearn.model_selection. I had to use that function, add my x, which is going to be my data, y, which is going to be my prediction, I'm assuming, my pattern, the section in my data set that my model used in order to learn pattern. Test size, which is 0.2, test my model with 20% of the actual data set and train my model with the 80% of my data set. Random_state42, which is just in charge of making my code reproducible, so every single time I run the program, I'm going to get an accurate and the same exact result, and the results won't change. Why is my break still going on? And then print x_train. This is just me printing their before shapes, and this is just me printing their before shapes. And then I go ahead and train my model using the model.fit method. To create my model, I use linear underscore regressions as function, which makes my model a linear underscore regression. Well, which gives my model access to all the methods that the linear underscore regressions as function actually had. It's like I won't call it an object because we're not working with classes here, but you guys get the gist of it, right? Whatever is it that my linear underscore regressions as function returns is what my model is actually going to be consisting of in the memory. And then model.fit to train my model, x underscore train, y underscore train, the two values that it needs to train my model. Prediction is model underscore predict, x underscore test. I want to predict my test score. Later on, I compare my test score with my x underscore test here. And then I print my prediction, I print my y underscore test, which is my test score. Y is like the answer key, the literal test score. X underscore test is, just let's say an example testing, if it makes any sense, just to see how accurate our model is, which it kind of was sort of accurate when compared to a few datas which was kind of inaccurate. MAE, I create a May variable. I set that equal to the result of my mean underscore absolute underscore error, the function that I included from my sklearn.metrics. I got y underscore test prediction, and then I went with numpy.square root because our RMSE squares our errors. I gave it my y underscore test and my prediction, I printed them, and was that pretty much it for our model? I just summarized that whole damn thing. But wait, why? Now, goes over our data set and calculates the error. This describes what you did to evaluate the model, not what the model does. A client does not care that you calculated errors. They want to know what the tool is for. Okay, wait. Let me say I do not have any clients and probably will never have okay, I don't want to go with that. Okay, I do not have any clients, and why do I even need to learn this while I am building my skills question mark? Do I not need to learn this later when I get better at AI engineering? Hold on. Cause why do I even need to know the skill though? Alright, I guess. Bro, that means I was done with building my model on day 100. I could have started my phase 3 today exactly as planned. We had miscommunication. Also, if you guys don't like my learning method, definitely tell me, because I do actually go over the learning methods that you guys even tell, and if I do like it, I kind of augment it in my current learning method, because I do need to learn docs as well. But I feel like if I copy the docs and send it to Claude and then say Claude to really teach me, it saves precious time. Okay, that's it. For a question, let's answer it instead of just pushing forward, because if you don't apply the why, you'll have as this and it won't stick. Here's the honest case for why this is on the roadmap right now, not later. This isn't really about having clients. It's about a skill that has nothing to do with client-facing polish and everything to do with something else you'll need for the rest of this entire 365 days series. Translating a number into a decision. Every phase from here on forward, RAG evaluations, agent reliability, fine-tuning comparisons ends with you looking at a metric and having to decide, is this good enough to ship, and what are the risks if I do so? That's exactly the muscle memory you just used for the last 20 minutes. MAE is $45,000, RMSE is $62,000. Therefore, so what? If you can't answer, so what? The number is just a trivia. You already proved you can do the hard part. You correctly reasoned through the whole RMSE versus MAE gap from scratch, self-corrected your own arithmetic, and landed on a real defensible insight. Uneven reliability across houses. The writing struggle. You're hitting right now isn't a knowledge gap, it's translation practice, and translation only gets built by doing it, by not by shipping it and hoping it appears later when you get better. Practically, if you skip this now and hit it again in phase 4 RAG evaluation or phase 6 agent reliability, where you'll be explaining to yourself or an audience why an agent failed, you'll be relearning the same skill under more pressure with more moving parts and less patience. Doing it now on a model you understand cold. Oh, I see. It's the cheap. Oh, I said. That said, real check-in, no judgment either way. Are you fatigued right now? Oh, I am not fatigued. I am, not fatigued at all. And I see what you mean. Okay, can you, ask me questions? Can you, simulate asking me questions, and answering those questions as well, because I want to see how are those questions answered before I try to answer them myself. There we go. Okay, and hold on, let me fix my typos real quick. Before, let's fix that, and then fatigued, let's fix that, and is that a punctuation? Okay, and then I guess let's send it. Do you realize writing is completely separate from AI, right? Like, once you're out of this and in the real world, X's aren't going to be asking for exactly what's the difference. They want a summary. You know what? That is something that actually makes sense, because, so far what I've been working on is learning the way programmers actually communicate, but real people wouldn't actually know this, so I do need to actually, work on translating the code. You know what? I guess one more skill isn't that bad, right? I think it's a pretty good skill, to be honest. And also, our timer kind of ended a long time ago. Hold on. I'm gonna actually play a bot. Let's go ahead and restart this. Hmm. I beat a 1,000 Elos' chess bot. I even beat a 1,200 Elos' chess bot. Let's try beating a 1,300 Elos' chess bot. New game. Let's be random and let's play. I'm gonna go with e4. I always do e4. I cannot really keep the center, but this time let's try to keep the center. Okay, I want to go with the King's Indian opening because that's easily the most secure opening. This is the most book opening ever. What if I go with the center push from here? Just like that, the center is mine. Oh, okay. I need to pin the... Okay, I need to push the pinned piece. Alright, let's protect this. Oh, wow, they're trying to push this. I do pretty good when it comes to actual bots, but it's hard to fight against anyone else. Alright guys, this is actually the first time in my entire chess.com's history. It's the first time I'm gonna use the En-passant. There we go. That's it. I feel like my life has been worth it now. Okay, even though that was a bad move, I just wanted to do it. That was a bad move, actually. Oh, it was a really bad move. What the hell? That's one of the worst moves. Let me break the mid. Let me break the ice. If I do that, the queen can actually take me. Therefore, I'm not gonna do that. Rather, let's move my knight. How am I losing the center? Okay, I'm gonna kind of pressure the pin piece. I take, queen takes, I take. I still have the d file. Okay, so I'll take this. I still have the center, to be honest. Nope, this is the best move, actually. My rook has access to the entire d file now. No more queens. That's a check. I'm gonna kind of avoid the check being 100% safe. And okay, they knew that I could have taken the pawn. So I'm gonna take the pawn because it's practically free here. But the knight can go there. The knight can go ahead and fork me. I need to get rid of the knight. Can I? Okay, so if I go there, I can protect that file. But then that file won't make sense. So I could go somewhere here. That is the safest d file in my opinion. I'm an idiot. How did I see that? How did I not see that? Okay, my knight is basically protected, to be honest. If I were to... Oh, wow. I hope it's not going to be a stalemate, is it? I'll take a stalemate. Okay. I guess we're not going for a stalemate. Yo, clip this, clip this. Wait, it's 10. It's 10, okay. How did I manage to stalemate a bot? What? Wait a minute. Let's go with 110-0. How did I manage to stalemate with a bot? Okay. Alright, I guess let's go with the rematch. We got enough time. Okay, now I'm black. I'm pretty sure when being black, King's Indian is a really defensive opening, so I'll go ahead and do that. Okay, and then we do this. And then we do a kingside castle. I'll go ahead and let's say take this. Let's go ahead and take this. They get access to the D file. Honestly, I'll let him take it. I'll let him take it. No, I can. It's a knight. It's a knight. So this is the safest position for my knight is right there. I don't want my knight to retreat though. From here, I can go there. I can come back up here because I want to just, you know what, let's go there. Safest knight position. Okay, the D file is mine. I want to go back, there. Take stakes. There. I take, you take. Okay, if I'm actually gonna lose, I may go out with the knight. Yeah, I'm definitely losing a knight. I should have seen this, to be honest, but I can kind of ruin their pawn structure from there. But then if I go up there, takes, I open their entire H file. This is making my brain hurt. Pawn for a knight, sure. Okay. Now, I'm gonna let their pawn structure be kind of ruined. Wow. Okay, half my board is not even active right now. Half my main pieces. King can move it. What did it take? Just a pawn? A fork? King moves. I go there. Wait, can I go there for getting like a free, no, I can't. Let me just check my king, check the king again. Okay, a rook. Damn it! Oh god, I should have seen that. Oh my gosh. Okay. How did I lose a rook? Their knight is protected. Can I check from there? But then I I don't have any protection. Why? What is my knight doing? I can go there. I want to kind of pressure their knight. I'll do the bishop trade. It's a good trade. Let's do the knight, to be honest. I mean the rook. Okay, I can move on, let's say out here. That's a safe place. Okay, that's a check. Oh my gosh. Okay, that's enough. That's enough, chess. I'm way too exhausted playing this 1300 elos as bot. Okay, so example, totally different domain. A weather app rain prediction. This tool predicts whether it will rain tomorrow using using temperature, humidity, and wind data. On average, its predictions are wrong about 1 out of every 10 days. That error isn't evenly spread. That error isn't evenly spread though. The tool is highly reliable for clear, stable weather patterns, but noticeably less reliable during rapidly shifting conditions like an incoming storm front. If you're using this for a day-to-day planning, trust it. If you're making a decision where a wrong call is costly, like scheduling an outdoor event during storm season, treat its predictions with extra caution. See the shape, what it does, accuracy, stated plainly with a real number, the reliability isn't uniform. What that means for trust, that's exactly same shape your housing write-up needs. You swap rains for housing prices. Okay. How would I write it for housing though? Hmm. Hold on. Okay, let's see. Oh, wait a minute. Hold on. Okay, alright, okay. You know what? I think I'm gonna just end the stream right now. Because I'm basically pretty much done with this entire thing. The model predicts based on line 2 state the MAE. You know what? I will probably work with this later on as well. But for the time being, let me just go ahead and